Welcome to pre-calculus video for skill number 13. I can translate between numerical, algebraic, and graphical models and use this to solve problems or make predictions. Alright, so now we're transitioning out of our map unit and we are moving to the next unit. Below you see a graphic which you would often find on a map. The trivia question is, what is this graphic called? Alright, we'll start our notes on page 13A. This skill is particularly good for understanding through the use of the assignment. So this video should serve really as a very minor precursory to practice problems, because these sort of practice problems show up in all different sorts of forms. So I'm giving a really brief overview of what exactly this skill is. The idea is we're talking about mathematical models, and these are structures that approximate phenomena for the purpose of studying or predicting their behavior. And we've been doing that since the start of the year. We used numerical models, so oftentimes that's organized in a table, so looking at a table of values that shows the behavior of some sort of system. An algebraic model is the formulas or equations that express relationships, and these are stronger than numerical models because they allow us to make predictions. You input a value and it spits out an output. And then finally we have a graphical model, which is a visible representation of your mathematical model, your numerical or algebraic model. Oftentimes a graphical model is useful in the sense that it gives us a quick snapshot of what's really going on. So here's an example of some sort of question that relates to this. A taxi charges $5 for fare plus 60 cents per mile. So we're told about a phenomenon, and we need to express this relationship or phenomena in three different models. So we have the numerical, the algebraic, and the graphical. So for the numerical model, I've made a table where you input the miles that you drove in the taxi, and then it spits out the cost. So your initial is $5. If you go 1 mile, you're going to pay $5.60, 2 miles and $6.20. And these values you could have just kind of pieced together, or more easily, your brain probably actually created an algebraic model which models the phenomena that's being discussed in example 1. 60 cents per mile plus the $5 fixed fee. And over here on the right, I've drawn a quick graphical model showing that as our miles go up, our cost is going to go up. For the skill test on this, what we're going to do is learn to translate between these three models pretty interchangeably. I'll show you a few graphs and you have to tell me, and I'll tell you several stories, and you have to match the story to the graphical model. And then we'll probably also create some algebraic models given a numerical model. Moving to page 13b, we look at example 2 that we're given a numerical model and we're asked to use this to create an algebraic model and use our algebraic model to predict the population of Sarenval in 2020. So here's our table, and for those who know what regression models are, we could do some regression analysis, but in this case we're just going to assume that population is growing linearly, and we will create an algebraic model based off of linear growth. So, how do we do that? First we're going to define 1990 to be t equals 0, and this very closely resembles what we are learning in skill 7. In fact, skill 7 is kind of a precursor to skill 13. So if you want to go take a look at skill 7, that's another great resource for you. And we're going to take 2 points. I like to take the first point and the last point and use those as our data points. And with those 2 data points, we can create a linear equation. So using our first 2 data points, we first find our slope, and we find that to be equal to 19. y2 minus y1 divided by x2 minus x1, and this equals to 19. So we now know our m value is 19, so we can plug that into our point slope equation, and then we can plug in y1 for y1 and x1 for x1, and we get the following model. Y minus 250.1 equals 19 times x minus 0. And if we wrote it in y equals form, our slope-intercept form, we can use that to do predictions, which is what was asked of us. Make a prediction for the year 2020. So since t equals 0 is 1990, 2020 is year 30. So we can plug 19 times 30 plus 250.1 to get approximately 820.1 thousand residents of Sarenval in the year 2020. And our final example that I was going to show is an example where we're asked to create an algebraic model from a story. And this story says that a bakery sells round cakes and rectangular cakes. The 8-inch diameter cake costs $25, so that's our round cake. That's our round cake. And it has an 8-inch diameter. That's all the way across is 8 inches. Whereas the 9 by 12-inch rectangular cake costs $25. So our 9 by 12, not 25, $55. And it asks us to create an algebraic model describing the area of each cake to decide which is a better deal. So I've broken that down here. The area of a circle is pi r squared. So for our circular cake, our radius is 4. So pi times 4 squared. You could say that our model is either that or more specifically pi times 4 squared, which spits out an answer of approximately 50.2. Our rectangular model area is length times width, and that gives us approximately 108, or actually exactly 108 square inches. So if we find the cost per square inch, you're going to say cost divided by the square inches, and you get two different prices. And you can see that the round cake is oh so slightly less expensive than the rectangular cake. I encourage you to look through the examples in the textbook because there's a great variety of ways that this skill can be presented, and I've only given you a precursory glance in this video. Alright, thanks for watching the video for skill number 13. The graphic is called a compass rose, and it's used to show direction and orientation for the map. If you want to know more about this skill, I encourage you to check out my Algebra 2 video on skill number 85, which I should link below shortly. Thank you.